Hi, welcome to Barney Tech channel. Here we are going to see about REL 670 relay configuration part 1. It's a distance relay configuration. Before going into the configuration, let me see some brief introduction about this relay. This is the hardware of the real view of the relay. Here you can see X31, X41, X51. These are the binary input and output of the relay. X401 is the analog input of the relay. If we see the more advanced relay, they will have more number of binary input and outputs. Have X31, 41, 51, 61, so on. But when you go for configuration, when you see the configuration binary inputs naming, that will not match with X31. The name will not be exactly same, but they have a different naming. So before going into the configuration, we must know what is the binary input and how the naming of the binary input will be on the application configuration. First we will see the binary input. If let us take an example X31 and 32, when you combine these two code, if it has a 16 binary input, then the application name will have BIM underscore 3. If the binary input on X41 and 42, then BIM hyphen 4. The naming will be such that. Okay, let me see the binary output. If we go for binary output, let us take the same example X31. If this card has 24 binary output, then the name appear on the application configuration will be BOM3. If it is on 4, then BOM4. If it is on X41, then BOM4. Suppose if your output, for example, if X61 card has binary output 12, then the naming will be appear on application configuration is SOM 6 because X61, so the last number digit it will be added, but here BOM will not appear, SOM will appear on the application configuration. In this 12, 6 output is very fast, it is static outputs. This kind of output is named as SOM, and you can able to differentiate with other output because other output has 24, but this special type will have only 12. The card may be X41, 51, whatever may be. For here I am showing one example X71. If X71 card contain 8 binary input and X72 card contain 12 output, then this card will be appear on the application as a IOM, input output module, and the corresponding extension number will be added, that is X71, so IOM 7. So this how we have to identify. And if you have any milliamp sensor, transducer sensor, it will be denoted by MIM. This how we have to identify the binary input and output on a application configuration. Now we go to schematic. If you see the schematic diagram of the relay, it has two CT core. The first CT core it's coming for distance protection, and second CT core it's coming for overcurrent earth fault protection purpose. And having one VT core is coming on channel 7, 8, 9, and 10 and 12 two cores are spare, and channel level it's coming for synchronous purpose, that is coming from bus VT. and these are I have taken from the schematic. I have made it on the tabular column. Now we can see the binary input. In X31 it have 8 binary inputs, and corresponding binary input namings I have mentioned here. Similarly for X32 it has another 8 binary input, so totally 16 binary input. So according to this code in application it will have this name VIM3. Now we will see the binary output. These are the binary output. The code is X41, consists of 12 outputs, and when you go for X42 it has another 12 output. So totally 24 output present in this card. So this card will be named in application as a BOM-4. So our relay will have real view like this. X401 is our analog, X31, X41 are binary input and outputs of the relay. Now we can go into the configuration. We can open the software and we can go into our project file. In that, first we will go for application configuration. In application configuration, we will consider configuration with fresh. So first I am going to add a new sheet in my application configuration. For that I am going to insert on the top side of the menu. Over the insert you can see main application. If you click that, the new sheet will be open, and over the right side you can have the username. Over there you can double click and you can change according to your requirement. Here I am going to make analog inputs. In RHEL 670 we have to configure analog, binary input, output, everything we have to do somewhat different than this 670 series, having different configuration than our 615 and 620 configuration. So 650 configuration is the basics of the ABB relay, and 670 will have little bit advanced. So here first we will see how to configure for analog input. Before going to the configuration, I am going to make the heading for this page. You can get this text over the insert. You can see the option text. Here you can type your name and you can change your text format according to your wish. Here I am making current input. Now I am going to get the analog inputs. Before going to this, we will see a small slide which will help you for making this configuration. Little briefly I will explain how to get the analog input channels and how to configure. First you right click on the application sheet, and over here you can see insert hardware channel. When you click the insert hardware channel, you can able to see binary input, output, analog input. Now I am going to configure CT, so I have to choose analog input. When you choose analog input, the hardware module name you will get TRM40. Then hardware channel will be selected from 1 to 12. You can see the channel list. The channel 1, channel 2, channel 3 is belong to core 1. Correspondingly R, Y, B phase. So first I am going to select the channel 1 and I am going to make R phase core 1 to identify the phase and core easily. I am going to make the name on user defined name. After making, you just click OK. Like this I have made 3 analog inputs. After this analog input has to merge with signal matrix. So in order to configure on signal matrix for this analog signal, we have to assign a special blocks, function blocks. So to get these function blocks, you have to right click on this application pages and you can see insert function block. Over here when you click, you can see the basic IED function. When you click the basic IED, you can see many number of function block will be under this topic, but we need to select SMA. From 1 to 12 it will have the number of analog blocks. In this you can choose according to your wish. For this slide I am going to select 7. When I select that, it will ask cycle time. For production we have to use 0.9 or 3, maximum use 3 millisecond, because depending upon this the reaction it will take to our production. If you make a 8 millisecond, then our production will have a time delay of 8 millisecond of detecting this fault. So normally we go for maximum 3 millisecond selection for detecting fault. So we can select 0.9 also, it will be more accurate, but generally we go for 3 millisecond. So I have selected the 3 millisecond, and after this name you can type here the core 1 CT 3 millisecond, the block name. You can rename if you make any mistake, of if you want to change anything, you can change. Over the right side corner you can see user defined naming, or here you can retype your names, or you can change your name according to your wish. Once you inserted the block, now you see how to connect this block and this analog signal. When you go nearer to the analog, the mouse point will change into like hand, and when you click left click over here, and the point will be attached, and you can drag and attach where you want to connect this signal. So after connecting this signal, this block having another function, the output of the blocks, if you see the 3P, that is RYB, 3-phase current we can get at the single point. When you see below that AI1, it will give output correspondingly L1. Similarly L2 will give I2, L3 will give I3, N will give I4. Now if we see the N of the G7N, the 7 stand for this AI module 7, and N stand for the neutral current. Here I have only phase CT, neutral CT I have not connected, but if you want to see get the neutral current, this block itself will calculate the zero sequence of the 3-phase current, and it will give output on N. So if you want a zero sequence current, you can take output from N. So this block having many function, so it will be very useful. Similarly we have to create for 8 millisecond for metering purpose, that we can see while doing the logic. This is just a introduction. Similarly we have to do for voltage source also. Now we go into our configuration and we'll see, and you can watch clearly how I am doing the configuration, and I will make the naming corresponding to the channel naming. By this the analog input is came to end, and I think by seeing all this you can able to configure analog very easily. Now we will see how to configure binary inputs and output. Before going into the configuration, we will see a small brief introduction about how to take this block and what are the steps we have to follow. Same way for configuration of binary inputs, we have to right click on the application page. Over here we can see insert hardware channel. On this you can able to see binary input and output. If you want to insert binary input, you can select binary input. Here you can see BIM3 BOM4. BIM3 is our binary input. We have to select that, and next you will get the hardware channel. In this you will get 16 binary input, so you have to select corresponding binary input. Next, user defined name, you have to give naming for this particular binary input, and when you make naming and click OK, the binary input will be showing on the application configuration. Now this binary input we have to merge it over the signal matrix, so we have to make these special blocks. That is, we have to go to on right click on the application page, and you can see insert function block. Over here basic IED function. Over this function block you can see SMI. You can see over here SMBI, that is signal matrix binary input. When you select this, the block will ask name. You can make it as it is a VT MCP trip, corresponding name you can make. After making, you can see 10 input is having this block. For VT input we having one binary input, so there is no need of 10 binary input for this block. So we can remove other binary input, and we can have one spare. For any future additional purpose we can have a one spare, and I am going to remove remaining all. The procedure to remove all binary input is right click on the block, and you can see manage signal, and when you click the signal you can see this manage signal window. Over here you can see show in application configuration, show in signal matrix. You can see all binary input 10, it will be configured just like XXX. When you want to unconfigure on application configuration, it is not possible. First we have to unconfigure on signal matrix first, then only it is possible to unconfigure on application configuration. So for example, now I am going to start to unconfigure on binary 3 BI3. So I am selecting BI3 on signal matrix, and when I go for double click it was unselected. Once it was unselected, the corresponding BI3 of application configuration, we can see the white over the column blocks. The particular box it get whitened. That means now it is possible to unconfigure over that area. Similarly, when I select on that BI3 and double click, same way it was unconfigured. Similarly, we have to do unconfigure for all, remaining all 10. After making unconfiguration of all 10, we have to make it down page. It is the first page. Second page we will have the output signal. Over here we have to keep two output only, remaining all output we have to unconfigure. Once you unselected this particular binary input and output, you can press OK. Now you can able to see the block become very small, and you can able to see only two binary input. If you want to give naming for this binary input also, you can able to give by clicking on the binary input, and you can type the user defined name that you can see on while I'm doing the configuration. Now similarly, we need, if you connected to the binary input 1, yes, when the binary input 1 get the signal, the binary input will produce the output signal. So on binary input you can make the label, and you can use that signal to various configuration. Similarly, we have to do for binary output, but binary output we have to select, instead of SMBI we have to go for selecting SMBO. Now we go to our binary input and output configuration. By this, our part 1 gets over. In part 1, we see prologue and binary input and output, how to configure for RHEL 670. In part 2, we can see how to configure for main production. I think this section will be little bit useful for you. If you think this section will be helpful for your friends, then please share this video to your friend. Thank you for watching this video.